Okay, so 1.1 is a line, so we're going to hit a couple notes here real quick first. So increments is if we have something like a particle moving from x1, y1 to x2, y2. The increments in coordinates are, and it's going to be delta x is x2 minus x1, and delta y is y2 minus y1. So basically, particle motion is going to be something that we do the entire year, and we do it in many different realms. This is like the baseline of it. So this isn't really anything new. It's just the way that we're talking about it. It's just the change in x and the change in y individually. Obviously getting us to slope, which we'll be using again with particle motion.
Is that a triangle x or?
Yeah, it is a triangle, but it's called delta. It just means change in. If you end up having to take physics in college, you'll do a lot with that. Maybe you did in physical science potentially as well.
It's like changing temperature or something.
Yeah. Yeah, delta T. So then obviously slope of a line from P1, which would be x1, y1, to P2, which is x2, y2, would be our slope, which would be delta y over delta x, or y2 minus y1 over x2 minus x1. So that's just taking the previous thing and just putting it together.
Slope. Okay. At first, like, it looks so confusing with the P parentheses x.
Yeah. A lot of points will end up getting an actual name in the stuff that we do, so that's part of where that comes from. It's like you're going to have a name for the point and then whatever, because it'll say, like, find the, not like the distance, but I'm just going to use that as an example. Like, find the distance between this, or find the speed at which the particle moved from time 1 to time 2. So, like, that's kind of what that's, like, looking at and stuff like that. Y'all probably remember this, but a perpendicular slope is the opposite inverse. So if I had, like, my slope 1 is 2/3, my perpendicular slope is -3/2. The parallel slope is the same slope. So that would be M1 is equal to M2. And then we're going to hit some stuff with equations of lines here. So if we just have, say, the point AB, then a vertical line, nope, vertical's A, yep, would be x is equal to A, and then horizontal is the other one. So y is equal to b. So those are obviously, like, essentially the most basic lines that we can have. And then we'll have our other form. So we have point slope form, which will be the one that we use the most in here, at least initially doing the setup. A lot of times this book will leave answers in point slope form, and there's kind of two different ways that they will show it. So write the answer, so I'll show you both. But this allows us to write, the equation of a non-vertical line if we know the slope in a point. So we would use our slope. So this formula comes from if we have y minus y1 over x minus x1 is equal to m. All this is a manipulation of the slope formula. I multiply both sides by x minus x1, and we get y minus y1 is equal to m times x minus x1. A lot of people don't recognize that when they're trying to sit there and memorize point slope form, but it's literally just the slope equation multiplied by x minus x1. And I mean, you could still say like y2 minus y1, I forgot to write the one, and x2 minus x1 technically, but obviously, typically when we're writing an equation of a line, we don't know something. We're trying to find the other point, so that's why it's written that way.
I didn't even realize that. Like,
most people don't realize like how similar it is.
Yeah. It's just the slope formula. You multiply the x's out.
Yeah. So yeah, it's crazy.
You mean divide by?
No.
We'll multiply by this to get.
Yeah, up top.
Yeah.
So you don't have any fractions.
I was thinking working from that way to that way.
Yeah.
But yeah, you can do both.
Now, a lot of times, obviously, pretty much up to this point, we've always written our answers this way if it asks us to leave it in point slope form. Unless it specifies, like, I don't care, but there's a lot of times we'll be using this to plug stuff in. But just so that you're aware of the other way that this book, if I remember correctly, there's two books, I think, that do this, but it'll sometimes do it as y is equal to m times x minus x1 and then plus y1. The only real advantage to that is it's closer to slope-intercept form if you're actually graphing the line. But that's just how the book demonstrates that part for you. So that's point slope. Then we have slope-intercept form. And with that one, that's just our usual y equals mx plus b. And then the last one is the one that we use the least probably, and in this class in particular, we very rarely use it, but it's general. We usually just call it general, but the book calls it general linear form. But this is the one that's ax plus by equals c, and this is assuming that a and b are not equal to 0. One can be equal to 0, but not both. We also sometimes call this standard form instead of general form. That was kind of another name that we used for it. So I'll just note that there. So every single line that we have, even if they have an undefined slope, have this form to them, because this is just something as simple as my equation of a vertical line or my equation of a horizontal line. Ax plus by equals c, x equals obviously a in that case because of what we had, but the baseline, every single line can be written in standard or general form. Okay, so a few problems here. Find the coordinate increments from A to B. So we've got point A is -3, 2, and B is -1, -2. So I'm just finding the increments for each one. So delta x is equal to -1 minus a negative, so +3. So that's just 2. And then delta y, -2 minus 2, -4, and those would be the increments for that. Obviously, once you found those, if you wanted to find the slope of the line or whatever between the 2 points, you could do that, but we don't have to with these.
Yeah, which is just like
Basically. Just the top and just the bottom of your slope formula, basically. The next problem, say, let L be the line determined by points A and B, It says plot A and B. I'm not going to make you do that because I trust by the time you are in calculus, you can plot a point on a graph. But we are going to do the find the slope of the line, and I'm not even going to draw it because, again, if you can plot points, you should be able to draw a line between the two of them. So we're going to kind of skip that part. If you want to do it when you do your problems, you can, but yeah. So number 8, we have A is the 0.12 and B is the 0.1 negative 3. So slope, we've got negative 3 minus 2 over 1 minus 1. So we've got negative 5 over 0. And what does that mean?
No slope. Well,
Undefined.
yeah.
Yep, so if 0's on the bottom, it's undefined. And remember, if 0's on the top, it's a 0 slope. Write an equation for the vertical line and the horizontal line through point P. So we've got negative 1 and 4/3 are the coordinates of the point. So remember, vertical is x, horizontal is y. So I quite literally just have x equals negative 1 and y equals 4/3. Good so far. 14. Write the point slope equation for the line through point P with slope m. So we've got the point is negative 1, 1. Slope is negative 1. So a lot of times this is going to happen. Either you will have found the slope and then be writing the point, or in some fashion you're going to have to find this information and write the equation of the line for a lot of what we're going to be doing relatively early on in the year. We'll be using that and writing the equation of a tangent line, but using the information that we're given. So plugging it into our formula, and it says to write a point slope equation, so that means you can leave it in that form, and I would take it in either form, like what we talked about up here, where you can write it either way. I typically leave it here, but the book is going to leave it here. So we've got y minus y1. So y minus 1 is equal to m negative 1 times x minus negative 1. So that would be plus 1. Leave it there if you want to. Book's going to add the 1 over here. And so it would be... No, because it says to leave it in point slope.
Oh, okay.
So the book's going to leave it like this. I would just leave it here. I mean, it doesn't matter. It's up to you which way you want to do it.
In the AC test, would they take either of them?
Well, truthfully, a question like that isn't going to be a free response question. That would be a multiple choice, so you would just have to pick which one they've written if they did it that way. I mean, they're not going to ask you this, obviously, exactly, but if they were like, write the equation of the tangent line to the curve, which is something we'll eventually be doing, then yes, they would, most likely they're going to go ahead and put it all the way into slope-intercept. But if they left it in point-slope form, yes. And like on a free response question, I don't know that I've ever seen one that asks for the equation, but I can't remember off the top of my head. There's such a variety of questions in calculus, but I would say that they would take it in any format that you left it of the ones that we listed, as long as it doesn't specify. So write the slope-intercept equation for the line with the slope and y-intercept. So 20, let's do 20. 20, we've got the slope is 1/3, y-intercept is negative 1. Y'all probably see why I said this stuff's kind of boring. They've literally given me the slope and the y-intercept. All I need to do is plug it into y equals mx plus b. So y equals 1/3 x minus 1. That's why I'm like, the first chapter is thoroughly boring. Write the general linear equation or standard equation of the line through the 2 points. So this one we actually have to do a little bit more work. 24. We've got the point -2, 1 and the point 2, -2. So I first need to find my slope. So I got -2 minus 1 over 2 minus negative, so plus 2. So I've got -3/4. So now I can take either of those 2 points and put it into point slope form, and then I just need to remember that they want it in standard form, so I just need to manipulate it from there. Do y'all want to use the first or the second one?
You use the first.
Okay. So we've got y minus 1 is equal to, yep, I think I was being crazy, -3/4 times x plus 2.
And then move. Yeah.
So, yeah, I'm going to have to move this over, and I would go ahead and distribute this, but I'm going to go ahead and move the 1 over all in this step. So y equals -3/4 x, and then minus, 3/2 plus 1. And so then what I need to do is I need to get the x and y terms on the left, and then the numbers stay on the right. I don't have a common denominator, so I'm going to need to get one. If you want to write those steps out, like we've kind of done that last year, we kind of were starting to get away from that. But if you can just do that kind of like mental math and like not have to worry about it, that's totally fine. So this is going to be 3/4 x plus y equals, so this is 2 over 2 minus 3/2, so -1/2. Now, I would just leave it here in most cases, but just for your reference, the book, I'm not going to say they don't like fractions, but they try to eliminate the fractions, so they multiply the entire equation by 4. And so when we do that, then because it's the whole thing being multiplied, we can do it, but it leaves me with 3x plus 4y equals -2, and so it's just a little cleaner way to look at it.
Why don't you just put it in decimal form?
Well, we pretty much never ever use decimals.
I was about to say. I've never seen decimals.
Unless it's just like a final answer of like speed is blah blah blah, but even then they still usually are in fractions. So like I said, I wouldn't care. I would have totally just left it in the fraction form if I didn't see what way the book wrote it, but that's what's happening. So another thing just to be aware of, like I said, this stuff straight up isn't going to be on the AP exam, but if you're at a multiple choice and you're like confident you've done it right and you're like, well, I have fractions and their answers don't have fractions, this might be what they did, is just take and multiply everything to just kind of simplify it down. So just a thing to be aware of. The next one, say to find the slope and y-intercept and graph the line. Again, I'm not worried about you graphing the line. I'm pretty confident y'all know how to do that. So 28, we've got x plus y equals 2. So just because of the format that it gives it in, I would move the x over so that I can find my slope and my y-intercept. You can probably mental math it, but y equals -x plus 2. So my slope, -1. Intercept is 2. write an equation for the line through P that is parallel to L and perpendicular to L. So we're writing two separate equations. So for 32, they've given us the point -2, 2, and then they've given us the line 2x plus y equals 4. So I need to figure out what the slope of this line is, and then I'll use that to find everything else. Yep, so we have y equals -2x plus 4. So this slope is -2. So then for parallel, we've got the same slope. So parallel line, the parallel slope is -2. So then I've got y minus 2 equals -2 times x plus 2. You can leave it there or take it all the way down. Up to you. I'm just going to leave it there for the sake of time. Perpendicular slope would be what?
Positive
1/2.
1/2.
Yep, positive 1/2. So then we've got y minus 2 equals 1/2 times x plus 2. And again, I just leave it there. All right. Find the value of x or y. So basically, they're going to give us 2 points, and one of the pieces is going to be missing, through which it has the given slope. So 38. They've given us the point A, which is -8, -2, and then B is x2. And then the slope is 2. So they try to make this one a little like crazy, but it's actually really easy. We're just solving. So we've got,
2 is not for x.
yep, so we've got 2 is equal to 2 plus 2 over x plus 8. And what I would honestly do here is I would just take and swap these things. I wouldn't like distribute it, move it, and do all the things. I'd literally just swap these. So I end up with x plus 8 is equal to 4 over 2. Obviously, that reduces down, try to put a line to it, to 2. And then subtract 8. So x is equal to -6. And you can always plug it back in to check and make sure that it works when you're done, in case you're not sure if it is or not. Any questions about that? All right, problems. I'm gonna say 1 through 21 every other odd, but basically you're doing one of the odds from each section. So I don't really care if you do that exact one. And then we've got 27 and 31 and then 37. So, and like I said, you won't actually be turning this stuff in. This is more like for you. I mean, I'll still give you like homework grades and stuff, but I also am going to go ahead and post the notes for the next section so that y'all can do those this weekend. So on Monday we can do that.